Now let's do some chemical reactions that carbon atoms show. So far we have studied what are the different carbon compounds that exist in nature. We have studied how to name them. We have studied what are the different types, how our different heteroatoms can be attached, and what will they be called after that. But we do not know for sure yet what are the chemical reactions that are shown by different compounds of carbon. So let's study some basic chemical reactions. The first chemical reaction is combustion. In the pure form, by pure form I mean C. So as maybe as a diamond, maybe as graphite, or maybe as fullerene. In the pure form, carbon combines with oxygen to form CO2. Right? In the saturated form, carbon atoms burn with a clean flame. So CH4 plus oxygen burns with a clear flame. Clean flame, this is what you see when you see the stove in your home, in the kitchen. So the stove gives a clean blue flame. There's no soot in it. There's no black colored substance depositing. That kind of clean flame is given only by saturated carbon. And we studied that saturated is when carbon bonds with a single bond with other carbon atoms. Unsaturated chains of carbon atoms burn with a sooty. Sooty, by sooty I mean a black deposit that happens. And yellow colored flame. This is what happens in a candle. If you put a spoon over a candle, the base of the candle, base of the spoon will start turning black, and as you see, the flame is yellow colored. So that implies that the burning here is occurring of an unsaturated carbon atom chain, and this gives a sooty yellow flame. Even sometimes it happens that the bottom of the utensils in the home start turning black. It's an indication that there's not proper oxygen supply, the air holes are blocked, and because of which the burning process is not happening properly, and that is why there's soot in the process. So what do we do then? We check the air blockages. We check if the holes in the stove are all open, and once the holes are cleaned, and then proper oxygen can be supplied to the fuel, and that is then it will burn properly, right? Why do some substances burn with the flame and others don't? So this is a question that is given in the yellow box. The interesting idea here is if you've seen an angeethi or coal burning anywhere, it turns red and it gives a lot of heat. But still it does not give a flame, right? So it doesn't show a flame. So flame is shown only by wood or by candles or in a stove. What is so specific about these things that they give a flame while others don't? The reason is presence of volatile substance. Right? So flame is only given when there's a gaseous substance which when burns evaporates in the air, and that leads to the formation of a flame. So flame does not indicate the intensity of burning or the temperature, but it only indicates one thing, which is that the compound has volatile material present in it, right? And that is why some substances show flame, whereas others like coal don't, because they exist in solid form. Now, before we move on to the next property, there's another burning aspect, another combustion which is very important to us, which is burning of petroleum and coal, because it is what we use to supply, to make our vehicles move, and it is what we use to run the electricity in our houses. Majorly energy in India comes from thermal power plants, which burn coal to produce energy. So before we go on to understand how does coal burn and how does it pollute the environment, we should know where does coal come from, right? So what coal actually is, it is the debris. Debris means the remains of living organisms which were buried under the earth for millions and years, billions of years, deep in the earth with high temperature, high pressure, and that decays them. The high temperature, pressure, and the time decays them, and they go through a lot of geographical processes. After that point of time, it turns into something called as coal or petroleum or other fossil fuels. So all fossil fuels are formed by the same idea. It are formed by organic compounds which are buried deep under the earth for millions of years. That is how coal and petroleum are formed. But what happens when we burn them? If burning, there's not much talk of why we should not use stoves. There's a lot of talk of why we should stop using carbon, why we should pool our cars or use public transport. Why is it that burning of coal causes so much pollution? It is because when coal is not just pure carbon. coal has sulfur and nitrogen in it. And when we burn it, the sulfur and nitrogen form sulfur oxides and nitrogen oxides, which are very, very harmful. Sulfur oxides and nitrogen oxides can cause serious breathing problems and can cause multiple skin problems also. And they also cause harm to the environment, harm the atmosphere. And that is why burning of coal and petroleum is especially a concern in today's world of how it will affect the quality of air around us. Right? So in combustion, we have studied that pure carbon burns with oxygen simply to form to form carbon dioxide. If there's saturated carbon, it burns with a clean flame. If it is unsaturated carbon, it burns with a sooty yellow flame. And and also sometimes when the air supply is inadequate, we need to clean the air holes in the stove just to make sure proper air is coming in, and that the process of burning can be carried out without any sooty flame. Then we talked about what is coal and petroleum, how is it formed, and how does it affect the quality of air. That is majorly affected by the presence of nitrogen and sulfur, which can form oxides, which forms oxides on burning and harms the environment, the air quality. Another thing that you can understand here is ethine. Ethine is an unsaturated carbon atom which is burned with pure form of oxygen. So ethine and oxygen together are used for welding. When ethine is burned in the presence of oxygen, pure rich oxygen, then it releases a lot of energy, and that energy is used to weld together metals, and this process is called as welding. Now let's talk of the second property, that is oxidation. Now we already studied that it burns in the presence in combustion. Carbon combines with oxygen to form CO2. So normally the process of combustion is also a process of oxidation. But some carbon compounds show some special properties that we'll be talking about here. That is alcohol. So this is ethanol, right? Two carbon atoms. Ethanol gets converted to carboxylic acid of acetic acid. This is called as acetic acid in common terms, but it is also scientifically called as ethanoic acid. So basically, alcohol gets converted after oxidation to carboxylic acid. Now, how does the oxidation take place? Alcohol will not convert to carboxylic acid on its own. It needs an oxidizing agent. Oxidizing agent is anything that helps in addition of oxygen to one element but does not participate in the reaction on its own, right? So the oxidizing agent that we are using here is acidified alkaline potassium magnate or potassium dichromate, right? So acidified K2Cr2O7 or alkaline KMnO4 can be used as oxidizing agent here. So these are called as oxidizing agents. They help in addition of oxygen to the compound without participating in the reaction itself. So on heating alcohol, it gets converted into ethanoic acid, and this process is of oxidation because oxygen is added here. The next reaction that we will be talking about is addition reaction. It is also called as, one of the types of addition reaction is hydrogenation. Right, so how does this reaction occur? What happens is, in an unsaturated carbon atom, like here, there's a double bond. The double bond breaks when heat is applied and when there's a presence of a catalyst. What is a catalyst? I'll get to that. The double bond breaks and now the vacant valency is now added on with new things. If it is added on with hydrogen, if more hydrogen atoms are attached, then it is called as hydrogenation. So addition is basically when a double bond breaks and something new is added on it. If it is hydrogen that is added, in that specific case, it is called as hydrogenation. The R here represents any number of series. It's like X in math. So R can represent any number of carbon atoms attached or any group attached. It can be alcohol, it can be acid, whatever. But when the double bond breaks and it lets addition of new elements on the atom, then it is called as addition reaction. It is done in the presence of nickel or palladium. Right, so there are two catalysts which can start this reaction, nickel and palladium. Catalyst is basically any substance which can either start a reaction or it can increase the speed of a reaction. This reaction might happen but occur very slowly. And when you add the catalyst, it increases the speed of the reaction. It does not participate in the reaction. The nickel that is added will come out as it's on its own just the same way. But it increases the speed of the reaction or it starts the reaction. Right? So this special reaction is called as addition. Now, how is it used in forming vegetable oil? So the animal fatty acids that are there, the fatty acids in the animals exist in double bonded forms and unsaturated forms. And it is not healthy for us to use unsaturated carbon atoms. So while making vegetable oils, they are converted into pure forms. So they are hydrogenated. And once they are hydrogenated to form these oils are better for us rather than consuming the direct fatty acids, right? So that is how the process of hydrogenation helps in the formation of vegetable oils. The next is substitution. This is the last property. So we have studied combustion, oxidation, addition, and then is substitution. So here the carbon atom has 4 hydrogen atoms attached to it. It sometimes allows, although this bond of C and H is very strong bond because both the atoms are very small in size, and that is why the bond becomes very strong because they are holding each other with a lot of energy. But sometimes it so happens in the presence of sunlight only, chlorine can be added here one by one. So CH3, so it will replace first one hydrogen atom will be released and one chlorine will be added to the molecule, right? And the remainder will be released in form of HCl. This type of reaction is called as substitution, where one H is substituted by a halogen.
Now, subscribe to Bright Tutee course at ₹1 per day only. Download Bright Tutee app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Tutee courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Tutee follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutee and avail your courses at affordable prices.